form the apply KVL equations and form the apply KVL and form the KVL equations. Okay, 47 are there. In 2 minutes we'll start. Till that, the rest who joined, please. This. Yes, I have shared this PDF.
Ma'am, we were doing superposition theorem.
Superposition theorem, ma'am.
Okay, this no. Actually, this one have you solved it? Kramer's rule I have explained.
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
Yours is B or D division?
D, ma'am.
Oh, sorry. I thought yours is B. Sorry. Yeah. So see superposition theorem. This one, sum. Sum how to solve I explained to all of you. Now start. You have to start, right? How to simplify.
आप एक बार फिर से बताने वाली थी कि क्या होता है सुपरपोजिशन पे.
हाँ, yes. I explained it last time how you have to solve. Okay. So just wait for 2 minutes for others and we'll start then. Those who got in the previous lecture how to simplify, consider 5 ampere, make 20 volts short and find the current flowing through 3 ohm. Okay, then consider 20 volt, make 5 ampere open and find the current flowing through 3 ohm. Do this. Those who got in previous lecture, start to solve in 1 minute. I will start lecture.
टाइम नहीं काय लक्ष दिसून तर 5 ampere 10 हे किती आहे 2 volt प्रीवियस आहे माहित तर आपण
Hello.
Yes, ma'am.
Yes, ma'am.
Can we start?
Yes, ma'am.
Yes. So see, everyone have to solve, because maximum priority, more weightage is for Kirchhoff's and superposition. Okay. So everyone please concentrate here how to simplify the sum using superposition theorem. Okay. So superposition theorem, I told you in last lecture that you can apply superposition theorem to linear circuits only. Okay. And secondly, minimum 2 sources must be there. 2 or more than 2 sources are there, you can go for superposition theorem. Okay. So here see, it's a linear circuit, resistances are there and time invariant sources are there. So you can apply superposition theorem. 2 sources are there, so you can apply it. One is voltage source, another one is current source. So what I told you in this sum, what you have to do, you have to find out the current flowing through 3 ohm resistance. Okay, see, find the current flowing through 3 ohm resistance using superposition theorem. So what we have to do? Yes, first thing is what?
We have to consider single sources at a time.
Correct.
Open 20 volt.
Correct. Okay, you have to consider single source at a time. Before it, what I'll do, whatever this original circuit, in this circuit, what is the load resistance? Current you have been asked to find out through what?
3 ohm.
3 ohm resistance.
3
Means
ohm.
this 3 ohm resistance you can consider as
Load
load
resistance.
resistance, RL. This 3 ohm resistance you have to consider as load resistance, which is denoted by R suffix small capital L. Huh? So R suffix capital L is 3 ohm. Got it, everyone? Load resistance clear?
Yes, ma'am.
Okay. Now what you have to do when all the sources are there in this circuit, you have to assume current direction flowing through 3 ohm resistance, load resistance. Okay. So which one you wanted to mark, you can mark. So see this one. Someone posted in chat box, this PDF is shared or not. So yes, this one sum is already shared with all of you. Okay. So what you do through this load resistance RL, when all the sources are there, you mark the current direction. I mark is upward. You can mark downward also. Got it? Okay. Is this clear? All of you? First one, when all the sources are there, you mark the current direction. You can mark upward also, downward also, clockwise also, anti-clockwise also, doesn't matter. Okay, so I considered upward. If with upward, I am getting minus, for example, I am getting minus 5 ampere, then with downward, if you consider, then your answer will be plus 5 ampere, provided you have done all calculations correctly. Got it? Clear? Okay, so I am going to consider when all the sources are there, means original circuit with 5 ampere with 20 volt. I am going to consider current flowing through RL is IL and it is in upward direction. Okay, it is in upward direction. Like this, I am going to consider. Okay, now next. What according to this, this is, I'll mark it as IL. Okay, what according to this theorem, this is the IL I have denoted. Okay, now what this theorem states, consider single source at a time and make rest sources inoperative. Okay, so for that what we'll do, which one will consider? First of all, I'm going to consider 5 ampere. Okay, inoperative, you have to make sources, means what you have to do with voltage sources?
Short circuit.
Short circuit, correct. And current sources?
Open.
Open circuit. Okay,
Open
so
circuit.
draw karo circuit, make 20 volt short. Okay, make 20 volt short and with only 5 ampere. Redraw karo circuit, everyone. Redraw it. See, circuit will be like this. Redraw karna hai, everyone. First, you have to draw circuit. Done? Once you finish, please tell me. Done?
Yes, ma'am.
Okay, so what we have to do, complete circuit as it is. Only what I have done here, I have shorted this 20 volt branch. Entire circuit will be as it is. Now see, 5 ampere will start from here. Okay. Then once it reaches at this node, it has two paths. Suppose I am going to denote, obviously current load resistance is what? 3 ohm. Now you have to find only current flowing through 3 ohm. That is the target only. Okay, that only we want. So obviously once current reaches, suppose I am going to mark this node as node A. Once this current reaches to node A, can you tell me in which direction current will flow through 3 ohm? Downward, upward?
Downward.
Right. Current will flow in the downward direction. Correct. Okay. So here I have marked, this is 5 ampere current flowing through 3 ohm. I have marked here I1 dash. You can consider it IL dash also. Mostly what is done RL, IL. Use IL here. Here I forgot to use IL dash. So this already I have solved. But all of you can represent it IL dash, or in next sum we'll take it IL dash. Okay. Let it be here. Otherwise, all of you will get confused again. So I1 dash. Okay. You can represent it IL dash also, load current. But here it is only with 5 ampere. So we cannot consider same variable. Here what I have considered IL when all the sources are there. So with only 5 ampere, different variable you have to select. Okay. So IL dash you can select, or here I have selected I1 dash. Okay. Now, once this I1 dash passes through 3 ohm, will any current flow through 4 ohm?
No.
No current will flow, means 4 ohm. This branch is called as 4 ohm resistance, means this one branch. This one branch, only this one. This is called as which branch?
Redundant.
Correct, a redundant branch. No current will flow through it. You connect it, you disconnect it, all values you will get same. Redundant branch. Okay. So 5 ampere, then I1 dash. If I1 dash is flowing like this, means through 5 ohm, how much current will flow? See, 5 ohm is reaching at
5 minus I1 dash.
correct. 5 minus I1 dash will be downwards. Now this I1 dash, it will flow through short circuit branch like this. It will come I1 dash up to this point. Now at point B, see at node B, 5 minus I1 is coming. This side I1 dash is coming. So sorry, here it should be 5 minus I1 dash. Please correct it, everyone. Okay, in the notes, what it should be? 5 minus. Hello, I1 dash. 5 minus I1 dash. By mistake, I have not written their dash. Okay, 5 minus I1 dash here it will be. So 5 minus I1 dash, and this side I1 dash is coming. So what will be this current? 5. Got it, everyone? Up to this. So how to find out I1 dash?
3 I1 dash equals to 5 minus I1 dash into 15.
Listen, everyone. This 5 minus I1 dash, make here everyone in your notebook I1 dash. By mistake, I have done this. Okay.
हम इसमें KVL लगाएंगे अब.
See, later on, any method you can use, which one will consume less time and you will not do any mistake. Okay. Got it? Whatever later on is convenient, that method you please use. Only the thing you should not do any mistake. And secondly, if possible, use less time consuming method. KVL अगर आप use करते हो Kirchhoff's law, so it consumes lots of time. Okay. Means it's a time consuming and possibility of mistake also more. Okay. Now 4 ohm is a redundant branch. Now what's about 2 and 3? How are they connected in?
Series.
In
Series.
series, right? 2 and 3 are connected in series. So that will be 5 ohm, right? And what's about 4 ohm in parallel with short circuit branch? What is its resultant?
0.
0.
Zero.
Correct. Correct. So draw karo circuit and find out, try to find out I1 dash.
मैम इसे फिर से redraw करें यहाँ के.
Ma'am, 3 points.
Always you have to draw the circuit, redraw karna hai circuit, equivalent circuit. See, this is the sign for equivalent circuit. Okay, so equivalent circuit mein kya draw karna padega? 5 ampere will remain as it is. This 5 and 10 you can, what's about 5 and 10? They are in series. Means what will be their resultant? 15. And what's about 2 and 3? They are in series. So their resultant
5.
5. And what's about short circuit branch and 4 ohm in parallel? 0. So see, it's equivalent circuit. 4 and this 0 ohm in parallel. Here it's a short circuit. No resistance will be there. 2 and 3 are in series. So 5 in parallel with it, 15, and this is 5 ampere. Equivalent circuit you got, everyone? Everyone got
Ma'am.
the हाँ yes.
हाँ, ये शॉर्ट सर्किट ब्रांच जो रहती है उसका भी करंट मतलब रेजिस्टेंस कुछ तो रहता ही है ना?
हाँ रेजिस्टेंस रहता है बट दैट वी आर गोइंग टू निग्लेक्ट इट. वेरी लेस रहता है. वेरी मीन्स उसका रेजिस्टेंस वेरी वेरी लेस रहता है. तो ये 4 ओम में से जो करंट जाएगा ना दैट विल बी वेरी
हाँ.
वेरी लेस.
ओके.
हाँ सो यू कैन
मतलब
निग्लेक्ट इट.
रहता 4 ओम में भी रहता है करंट.
हाँ 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 रहता है बट दैट मीन्स प्रैक्टिकली अगर देखते हैं तो वेरी लेस. क्योंकि ये देखो ये जो ब्रांच है ऑब्वियसली यू आर टेकिंग इट एज अ कॉपर वायर.
यस.
तो उसको तो कुछ तो रेजिस्टेंस तो रहेगा ही ना.
हाँ.
बट दैट विल बी वेरी वेरी लेस. सो क्या होता है मैक्सिमम करंट विल फ्लो थ्रू दिस ब्रांच एंड वेरी लेस अमाउंट ऑफ करंट फ्लोइंग थ्रू 4 ओम एंड दैट इज ऑलमोस्ट इक्विवेलेंट टू 0. मीन्स माइक्रो एम्पियर में वगैरह फ्लो होता होगा. सो
अच्छा.
निग्लेक्टेड. ओके.
ओके.
So means ideally क्या means practically what we assume that our short circuit branch resistance is 0. If it is a short circuit branch resistance is 0. So 4 and 0 ohm in parallel. 4 into 0 divided by 4 plus 0. 4 plus 0 is what? 4. Right? Means
Yes.
what you are getting 0 divided by anything. Right? Na? 0 divided by anything is what?
0.
0. Got it? That is the thing. Short circuit branch resistance is 0. Open circuit is infinite.
Infinite.
Clear? Up to this, everyone got it. This one step. See, 5 ampere
Yes,
as it
ma'am.
is. Then 5 and 10 are in series. So this is 15. So 2 and 3 are in series. So here it's a 5. And 4 and 0 in parallel 0. Okay. So their equivalent circuit, everyone got it? Okay. So see here I have written 5 minus I1 dash. Huh? Okay. So now which one current we want? We want current flowing through 3 ohm. Which one current is flowing through 3 ohm?
Load current.
I1 dash. I1
I1
dash. Okay, means in this circuit. In this circuit, whatever
Okay.
on screen, I have denoted it that I1 dash. Okay. So see, I1 dash we wanted to find out same current will flow through 5 ohm also in this circuit. In second circuit, whatever the current flowing through 5 ohm, I1 dash is same as that of current flowing through 3 ohm in earlier circuit, right? यहाँ पे जो 5 ओहम से करंट फ्लो हो रहा है I1 डैश, वही करंट यहाँ पे 3 ओहम में से फ्लो हो रहा है. यहाँ पे 2 और 3 सेपरेट दिखा है, यहाँ पे 5 एक ही रेजिस्टेंस दिखाया है. तो ये सेकंड सर्किट में जो भी I1 डैश आप फाइंड आउट करोगे दैट विल बी द करंट फ्लोइंग थ्रू 3 ओहम. राइट? ठीक है. तो अभी बोलो यहाँ पे कैसे फाइंड आउट करोगे? मुझे क्या करना है? करंट आई वांट फ्लोइंग थ्रू 5 ओहम. What's about 5 and 15? How are they connected in?
Constant voltage.
Parallel.
Parallel.
Correct. Across these 2 points, 2 nodes, 5 and 15 are connected in parallel. Okay. And do you know the current entering? Suppose I'm denoting this node as A and this one as node B. Across nodes A and B, 5 and 15 are connected in parallel. Do you know current entering 5? Do you know current entering node A? Do you know the value of
Yes.
current entry? How much it
Yes.
is? How much?
5 ampere.
Do you know current leaving node B?
Yeah.
Yes.
How
5
much it
ampere.
is? 5 ampere.
5 ampere.
Correct. Means total current you know and 2 resistances are connected in parallel. So can we go for which formula?
Current division rule.
Correct. Current division rule. Got it? So current flowing through 5
2.75
ohm.
ampere आएगा.
Correct. Current flowing through 5 ohm we want. What is the parallel resistance to 5 ohm?
15.
15. So that will come in numerator. Do you remember current division rule formula?
Yes.
Okay,
ma'am.
that comes
ma'am.
in numerator into total current. Total current is 5 divided by addition of two parallel resistances. Got it? So 5 is the total current, 15 is the parallel resistance divided by addition of two parallel resistances, 15 plus 5, 20. So 75 divided by 20 is 3.75 ampere. Unit लिखना है exam में. What is important here? See, whenever you are going to simplify it by superpositions, right? Considering 5 ampere current source and making 20 volt short. Okay, then the circuit will be draw करना है circuit, represent branch current direction, उसका simplified version if required, draw it, and then here no need to further simplify this circuit. Directly I can write current division rule. Whatever the current you have calculated, mention its unit. Clear up to this, everyone? And what is the direction? What is the direction? 3.75 ampere direction is
Downward.
downwards.
Downward.
Clear up to this means we have find out current flowing through 3 ohm considering only single source, that is 5 ampere. Now again, next step, according to superposition theorem, what it state? See here I have written 3.75 downward, or it is flowing in clockwise or anti-clockwise direction. See the circuit. It is flowing in clockwise or anti-clockwise?
Clockwise.
Clockwise. So any you can represent upward, downward, or clockwise, anti-clockwise. So both I have denoted here. Any one you denote in exam, okay, or while solving the sum. Just for your understanding, both I have denoted. Okay, I1 dash. Now what according to this theorem states? Consider second source and make rest inoperative. So considering 20 volt voltage source, and what's about the rest is 5 ampere. It's a current source. So you will make it open or short?
Open.
Open, because it's a current source. Circuit will be. Draw करना है circuit. Draw करो everyone circuit. Previous one, everyone have finished previous calculations?
Yes, ma'am.
Is it becoming fast?
No, ma'am.
No, ma'am.
So solve everyone this. Draw करना है. Keep current source open and consider 20 volt only and draw karo circuit. Then represent current direction. We have used previous one through load resistance I1 dash. Now you have to use I1 double dash. If you are using variable IL dash, IL double dash. If third source is there, then IL triple dash, like this. Here we have used I1. I1 is in original circuit, I1 dash with first source, I1 double dash in with second source, so on. Drawn circuit, everyone finish? Once you finish, tell me. Done with this?
Yes, ma'am.
Yes.
I1 double dash is equals to 1 ampere.
1 is
Okay, wait, we'll check.
मैम
So,
दिस
हाँ?
टाइम 4 एम्पियर से सॉरी 4 ओहम से करंट नहीं जाएगा क्या?
जाएगा ना, करंट
मैं
will go.
हमने शो नहीं किया है ना.
हाँ, because we are not interested in current flowing through 4 ohm na. See what I have done. 5 ampere you make open. Okay, rest circuit will be as it is. ठीक है, फिर अभी क्या होगा? This is only single source. So conventional current direction will use current. I'll start I have used variable I. It will start from positive terminal of battery. Now this node, suppose I denote A. So once current reaches node A, how many paths it has? 2 paths. One will flow through this 3 ohm branch and another will flow through 4 ohm. Through 3 ohm, how much I have denoted?
I1 double dash.
I1 double dash. And if this is I and this is I1 double dash, in which direction I1 double dash will flow?
Upper dash.
Anti-clockwise.
Upward. That is anti-clockwise. See, anti-clockwise upward. Got it? So if I1 double dash is flowing like this, means obviously through 4 ohm in downward direction, how much current will flow?
I minus I1 dash.
I minus I1 double dash.
Double
But
dash.
but here while calculate, we want only value of I1 double dash. That's it. So current flowing through 4 ohm, no need to show. Okay, we don't want its value. No need to mark the current flowing through 4 ohm. Got it? Clear up to this? Current flowing through 4 ohm is I
Yes, ma'am.
minus I1 double dash. Okay. Both variable are different. See, I is different. I1 double dash is different. And some current will flow through this and that will be I minus I1 double dash. Okay. Done. Now see, how much current is flowing through 3 ohm, 2 ohm. See, once this I1 double dash reaches over here, this side open circuit is there. So will it flow through this branch? Yes.
No.
It will not, because
No.
open circuit is here. So no current will flow through this open circuit branch. Directly through 5 ohm and 10 ohm it will come and so on up to this. Now can you tell me current flowing through 2, 3, 5 and 10 is how much? Or which one current is flowing through 2, 3, 5 and 10?
I1 double dash.
I1 double dash.
I1
Okay.
double
Means same current is flowing through 2, 3, 5 and 10.
Yes.
Yes.
Yes, means how are they connected in?
Series.
Series.
Yes,
If the resistances are connected in series, means their equivalent is you have to add them. Got it? So draw its equivalent circuit. See here, sign I have plotted. Its equivalent circuit will be what? See the equivalent circuit. Got it? 2, 3, 5 and 10. What will be the addition?
20.
20 ohm.
20 ohm.
Now this is 4. Rest circuit will remain as it is. This is 4 and this is 20 volt. Now can you tell me this 20 and 4, how are they connected in? 20
Parallel.
ohm and 4 ohm, right? They are connected in parallel. If they are connected in parallel, voltage across both of them will be same or not? Same. And how much it is?
20
20
It is
volt.
given, its value is given, and that is 20 volt. Got it? Means we are interested only in finding out which current. We want only I1 double dash. Okay. Through 20 ohm, which one current will flow?
I1 double dash.
I1 double dash. See, I1 double dash. That only we want. That's it. We don't have to do anything with the rest circuit. Okay. So resistance I know 20 ohm and voltage across it I know 20 volt. Got it? So 20 volt divided by 20 ohm, 1 ampere. All of you can cross check your answer. Someone was
Yes, ma'am.
asking. Okay.
Yes,
Clear? 1 ampere. So it will flow. Direction you denote in upward direction or in anti-clockwise direction. Clear up to this?
Ma'am, direction in 20 ohm downward, so an I1 double dash.
See, we are not interested in current direction through 20 ohm. We are interested only through load resistance. So current flowing through load resistance is I1 double dash and its direction only expected, not the current direction through rest resistances. We want only value of current flowing through 3 ohm. We want only direction of current flowing through 3 ohm. Clear? So whatever the direction represented here is only through load resistance. Is this clear to everyone?
Yes, ma'am.
We are not
ma'am.
interested in rest current direction or in rest current variables. ठीक है? Got it? Okay. So up to this everyone got? Okay. Now in original circuit, I considered variable I. Here you consider it rather than IL, you consider I. This one. Okay, this one. This current and direction is which one I have assumed here? Upward. Huh? So here upward I am going to mark is at rather than IL, I will use I1. Original circuit, when both the sources are there, current direction you can assume upward also, downward also. Which one I have assumed? Upward. Mute yourself, students. Okay, so that the others will not get disturbed. And this one I am going to put pass on recording, na? So mute yourself. So got it? What I have assumed I1. I1 मैंने कैसे assume किया है? I1 क्या है? When both all the sources are there. When all sources are there, 5 ampere is there, 20 volt is there. I1 I have assumed upward. You can assume downward also. ठीक है? ओरिजिनल सर्किट जो है उसमें लोड करंट आप IL वेरिएबल यूज कर सकते हैं, I1 भी यूज कर सकते हैं. डायरेक्शन आप एनी डायरेक्शन दिखा दो, वहां पे कौन सी भी डायरेक्शन दिखा दो, अपवर्ड दिखाओ, डाउनवर्ड दिखाओ, क्लॉकवाइज दिखाओ, एंटी क्लॉकवाइज दिखाओ, डजंट मैटर. ठीक है? क्लियर? सो आई हैव डिनोटेड I1 अपवर्ड. सो सी हियर आई हैव रिटन I1 अपवर्ड. है ना? अभी सुपरपोजिशन थ्योरम लगाना है. So see, I1 upward I have denoted here. Now I1 dash and I1 double dash, its direction is fixed. That you can't choose on your own. I1 dash, we got downward. I1 double dash, we got upward. So right over here. See, I1 I assume upward. I1 dash, we got downward flowing in the circuit. I1 double dash, we find out that it is upward. So with reference to this, mark the plus minus sign. See, I1 is in upward direction and I1 dash is downward. So it will be plus or minus here. Opposite hai. Minus. Okay, algebraic sum it is. And what's about I1 double dash? It is upward with reference to this original current. So this one also upward. So here it will be, both are in same direction. That's why positive. Clear everyone? अगर आपने यहाँ पे दोनों add कर दिए, तो what you will lose your marks, right? So don't do such mistakes in exam. So compulsory here minus 3.75 plus 1 minus answer you are getting. You are getting minus 2.75. What does it mean? Whatever you have assumed current flowing through load resistance in upward direction, this direction you have assumed is wrong. Okay, current will flow. Then you just write I1 is equals to plus 2.75 and direction is
Downward.
downwards. No need to write anything. If you wanted to write it. If upward is negative, just mention positive and with downward direction. Or if they ask specifically direction, then you mention current will flow in downward direction, or you can mark there 2 points, C to D. So current rather than D to C, it will flow from C to D like this. Clear? Got the sum using superposition?
Yes, ma'am.
Huh? Okay. So can you solve the sum on your own? Should I give you next sum?
Yes, ma'am.
Up to this,
Yes.
everyone have finished. Can we go for second? Huh?
Your voice is
Ah.
coming very low.
So see, is this visible to all of you? This one PDF. Next, using superposition theorem, find the current flowing through 1 ohm resistance. Okay. Actually, it's I scanned this na in more light, so its color different. I'll rescan it and will again forward to all of you. अभी आप ये solve करो तब तक. मैं फिर से scan करती हूँ तब तक इसको. Can you solve on your own? See,
Yes,
this is how much?
Doing, ma'am.
Voltage source 100 volt. In series with it 4 ohm. Here 50 volt and 1 ohm. And here 40 volt and 2 ohm. Only resistances are there and voltage sources are there. Time invariant voltage sources means linear circuit, and 2 or more than 2 sources are there. You can go for superposition theorem. Only the thing is here, what is the load resistance? See, what is the load resistance is?
1
1 ohm. So current through this you mark as IL. Then IL dash for this, IL double dash for this, and IL triple dash for this. Okay. So all are voltage sources. So solve करो. Consider करो पहले IL की direction दिखा दो, upward, downward, whatever you want. Show in original circuit. Then consider only 100 volt, and rest two you will make
Short
Short.
circuit.
short. And then current, we are interested only current flowing through 1 ohm, right? Yes, all of you. Then find out IL dash, IL double dash, IL triple dash with 100 volt, with 50 volt, and with 40 volt. Their direction also you will get, and do the algebraic sum. So what is the superposition theorem? Clear to all of you?
Yes, ma'am.
You
Yes, ma'am.
solve this. You solve this. Till that I'll again scan this proper, because यहाँ पे ये थोड़ा सा shade, ये upper one see, it's scanned properly. It's I think easy. It's to see. It's okay, but this one is blue color. I'll again scan it. All of you please solve. All of you can solve on your own, right? Yes or no?
Yes, ma'am.
हाँ,
Yes,
तो
ma'am.
solve करो. हाँ, मैंने अटेंडेंस लिंक पोस्ट की है चैट बॉक्स में. अटेंडेंस दो आप. अटेंडेंस, प्लीज मार्क योर अटेंडेंस एंड सॉल्व द सम. And those who solved with 100 volt, with 50, post your answers in chat box so that others also can cross check whether you are getting same answer, correct answer or not. All of you can share your answers in chat box. Solve karo everyone. Till that I'll again this scan करती हूँ इसको फिर से, and then that one clear copy I'll share on screen. हाँ, answer, see, all of you can post your answer so that you can cross check with others. I'll show to you solution also. Everyone please cross check. हाँ, yes, Yadav, Gaurav, you raised your hand. Ask, no need to raise the hands, directly you ask the question. Yes.
Ma'am, I have a doubt.
Yes, ask, please.
In previous example, what actually we did in I1 double dash? 20 V upon 20 ohm. वो नहीं समझा.
वो नहीं समझा. Okay, 1 minute. See now this one is more clear ना compared to previous one image.
Yes.
Yes, ma'am.
हाँ, ये फिर से scan किया है मैंने. Okay. Others solve till that. This I'll show you. One doubt. Okay. See, are you concentrating here? Who asked Yadav?
Yes.
See,
Yes.
see here 20 and 4 ohm are in parallel.
Yes.
So अगर दो रेजिस्टेंसेस पैरेलल में रहते हैं तो उनके अक्रॉस वोल्टेज सेम रहता है या डिफरेंट रहता है? सेम रहता है. यहाँ पे इनके ये कॉम्बिनेशन जो है पैरेलल, इसके सीरीज में कोई रेजिस्टेंस नहीं है यहाँ पे, तो दोनों के अक्रॉस मींस जो भी वोल्टेज है यहाँ पे अवेलेबल वो पूरा जाएगा, बराबर ना?
ओके.
हाँ, कितना रहेगा? इसके अक्रॉस 20 वोल्ट जाएगा, इसके अक्रॉस भी 20 वोल्ट जाएगा क्योंकि ये दोनों पैरेलल में है. ठीक है. पर अगर यहाँ पे अगर कोई रेजिस्टेंस रहता, सपोज ये मैं देखो यहाँ पे एक ड्रॉ करती हूँ, सपोज यहाँ पे एक 1 ओम का रेजिस्टेंस मैंने डाल दिया है, देन अक्रॉस दिस टू 20 वोल्ट इट विल नॉट बी, बराबर ना? हाँ, तो वो निकालना पड़ता था फिर 20 and 4 आर इन पैरेलल, देन उसका जो रिजल्टेंट आता है दैट इज इन सीरीज विथ 1 ओम, फिर उसको ऐड करो, फिर टोटल करंट निकालो और फिर करंट डिवीजन रूल से I1 डबल डैश फाइंड आउट करो. बट क्या है, यहाँ पे टोटल वोल्टेज दिया है और ये पूरा जाएगा ये दोनों के अक्रॉस, पैरेलल में है और तीसरा कोई भी रेजिस्टेंस नहीं है, तो ये दोनों पैरेलल में है, उनके अक्रॉस 20 वोल्ट है, इसलिए 20 वोल्ट वोल्टेज और 20 ओम रेजिस्टेंस, सो 1 एम्पियर. क्लियर?
ओके मैम.
हाँ, ठीक है. अभी देखो, अभी कौन सा सोर्स कंसिडर करना है? सेकंड सम. वी आर गोइंग टू कंसिडर 100 वोल्ट. ठीक है, 100 वोल्ट पहले कंसिडर करो. सी, अभी मैं आपको डायरेक्शन दिखाती हूँ, विच वन आई हैव अज्यूम फॉर IL मैंने क्या अज्यूम किया है? देखो IL मैंने क्या अज्यूम किया है? सी हियर, everyone see the PDF. IL what I have assumed? Downward. You can assume upward also. Okay, you can assume upward also. I have assumed downward, so that IL, see, 1 ohm is load resistance. IL is the current flowing through load resistance. RL direction you can assume upward also, downward also. I have assumed downward. Okay, so when all sources are there, mark the current direction in original circuit flowing through load resistance. Okay. Next is this, consider which one? 100 volt, and rest sources you have to make short, right? The rest sources you will be making short. So how the circuit will be? See, अभी देखो 100 वोल्ट एज इट इज रहेगा ये, और 4 ओम भी एज इट इज रहेगा. ठीक है, ये देखो यहाँ पे एज इट इज है. ये 50 वोल्ट है, ये क्या हो जाएगा? शॉर्ट हो जाएगा. ये 40 वोल्ट भी शॉर्ट हो जाएगा, तो 1 और 2 ओम. ठीक है, सर्किट गॉट इट एवरीवन? यस, ये सर्किट बी जो है वो समझ में आया सबको?
यस.
हाँ, कैन वी गो फॉर नेक्स्ट? हाँ, ओके. सो देखो अभी ये 50 वोल्ट शॉर्ट कर दिया, ये देखो ये शॉर्टेड ब्रांच. ये 40 वोल्ट शॉर्ट कर दिया, ये शॉर्टेड पोर्शन, एंड 1 और 2 ओहम है, यहाँ पे 4 ओहम है, ठीक है। नाउ वी आर इंटरेस्टेड ओनली इन दिस सर्किट, दिस इज द सी कंसिडरिंग 100 वोल्ट voltage source and making 50 volt and 40 volt short circuit will be like this circuit B. Now in circuit B, what is our aim is only to find out the current flowing through 1 ohm in circuit B. That's it, that only we want. So that I am going to denote it by IL dash. Okay, so see 100 only single source is there, so from its positive I will start. Once it reaches to node A, suppose I am going to mark it as node A, this one as node A here. So once this current I reaches to node A, it has two paths, through 2 ohm, through 1 ohm. So through 1 ohm, which one variable I have used? Yes, थ्रू 1 ओहम कौन सा वेरिएबल यूज किया है मैंने?
A.
IL dash.
IL
हाँ, and obviously it will be in which direction?
Downward.
Downward. Now here you can't say that I will consider upward, because all these points are at zero potential, right? So current always flows from higher to lower potential. So IL dash. Now can you find out IL dash? Simply see its equivalent circuit. What's about 1 and 2 ohm? How are they connected in?
Parallel.
See
Parallel.
in circuit B,
Parallel.
1 and 2 ohm are connected in parallel. So find out its equivalent. See 1 ohm and in circuit C, 1 and 2 ohm are in parallel. Its equivalent 1 into 2 divided by 1 plus 2, 2 by 3, that is 0.67 ohm. Clear? Have you got the calculation, everyone?
Yes, ma'am.
Yes, ma'am.
So उसका equivalent circuit
Ma'am.
दिखा दो अभी. हाँ, yes.
I use the KVL, ma'am, for equivalent.
हाँ. See, to find out IL dash, you can also use KVL also. But KVL, if you are using, I am telling to you that what I feel, that it is time consuming and maybe there is a possibility of some mistake. But if you are comfortable with that, you can go for that. Okay.
Okay.
ठीक है. हाँ. So see, 0.67 is the resultant, and that will be in series with the 4 ohm. And here 100 volt is the voltage. Its equivalent C circuit all of you got. C circuit कैसे आया, सबको समझ में आ गया?
Yes, ma'am.
हाँ, 0.67
Yes,
जो
ma'am.
आया है वो सीरीज में रहेगा 4 ओहम के, 100 वोल्ट एज इट इज. ठीक है, ये हो गया. अभी क्या करना है, पहले आपको IL डैश ये B में डायरेक्टली नहीं मिलेगा, उसके लिए कंपलसरी आपको I फाइंड आउट ही करना है. ठीक है, तो उसके लिए ये मैंने सिंप्लीफाई किया. फिर अभी आप इजीली I फाइंड आउट कर सकते हो या नहीं सी सर्किट में? कैन यू इजीली फाइंड आउट नाउ करंट I इन सर्किट C?
Yes, ma'am.
ठीक है.
Yes,
अभी
ma'am.
4 और 0.6 कैसे कनेक्टेड है? हाउ आर दे कनेक्टेड? सीरीज में, राइट? 4 and 0.67 are connected in series, so you can add them, and this is the total voltage. Okay, so total voltage divided by total resistance, you will get total current in circuit C. Got it, everyone? यहाँ पे B चाहिए था. Here I have written what? 1 and 2 ohm are in parallel. Actually here it should be B. ये minor correction please do on your own. Means you should use your own mind, your own brain, right? If some mistake is there, neglect it, correct it. यहाँ पे B कर दो, आपके यहाँ पे जो भी कॉपी है ना, यहाँ पे B कर दो. In circuit B, 1 and 2 ohm are in parallel. और यहाँ पे चाहिए था in circuit C. In circuit C कितना करंट आया है? This one. Got it? Yes? Clear up to this?
Yes, ma'am.
हाँ. अभी ये जो टोटल करंट आया है 21.41 मीन्स ये करंट है, राइट ना? ये बी सर्किट में जो आया है 21.41, राइट? इज दिस क्लियर? तो ये जो टोटल करंट आपको पता चल गया है अभी यहाँ पे, और 1 और 2 ओहम पैरेलल में है, तो IL डैश आप कैसे निकालोगे? See the circuit B. We want now
V
only
equal to
IL
exactly करते हैं
dash. Huh?
ओम्स लॉ यूज करें
क्या यूज करके? नहीं, ओम्स लॉ
ओम्स
नहीं,
लॉ को
ओम्स लॉ नहीं. Same. See how one, see everyone please see circuit B. Circuit B में do we get the value of current I? सर्किट बी में जो करंट कैपिटल आई मैंने दिखाया है उसकी वैल्यू मिल गई है या नहीं?
We have got 21.41.
21.41 मीन्स आपको टोटल करंट पता है, ये यहाँ
Yes,
तक
we can
आएगा.
find by 21.41 minus IL and IL.
मैं अभी जो पूछ रही हूँ उतना ही जवाब दो, ठीक है? टोटल करंट आपको मिल गया है. ये 1 और
Yes.
2 ओहम कैसे कनेक्टेड है? हाउ 1 and 2 ओहम आर कनेक्टेड इन
Parallel.
पैरेलल. ये टोटल करंट, ये पैरेलल कॉम्बिनेशन के अक्रॉस, अभी देखो ये टोटल करंट आपको पता है 21.41. दिस इज सपोज आई एम गोइंग टू मार्क नोड ए एंड दिस इज नोड बी. आई एम गोइंग टू मार्क. सो नोड ए को कितना करंट एंटर कर रहा है?
21.4.
21.41. और नोड बी को कितना करंट लीव कर रहा है?
Same 21.4.
21.41. और अक्रॉस नोड ए एंड बी हाउ 1 and 2 ओहम आर कनेक्टेड इन
Parallel.
पैरेलल. और मुझे आईएल डबल आईएल डैश चाहिए, तो क्या यूज कर सकती हूँ मैं?
Current
करंट
division.
डिवीजन रूल
करंट डिवीजन
Distribution.
रूल. करंट डिवीजन
Division.
रूल. गॉट इट? क्लियर एवरीवन? इजी है.
Yes, ma'am.
No need to go for KVL, but if you are more comfortable with KVL rather than this method, please apply, no issue. But I feel this one more convenient. Okay, so see, what is it? IL dash is how much? Total current I. But we want IL dash. IL dash is flowing through what? 1 ohm. Parallel to it is what?
2 ohm.
2 ohm. So take that in numerator divided by 1 plus 2. So how much is the answer? IL dash 14.27 ampere and in downward direction. Got it?
Yes, ma'am.
Yes, ma'am.
Everyone
Yes,
got
ma'am.
up to this? ठीक है?
Yes, ma'am.
Can we go for next?
Yes, ma'am.
Now consider second source 50 volt and make rest too short. ठीक है? तो circuit will be like D, as in D. ये D circuit सबको समझ में आ गया? ये यहाँ पे 100 वोल्ट था, यहाँ पे 40 वोल्ट था, दोनों को शॉर्ट कर दिया तो सर्किट ऐसे हो जाएगा. ये सर्किट सबको समझा है या नहीं समझा है?
Yes, ma'am. Got it.
हाँ, got it. Okay.
Yes, ma'am.
So if I am going to speak in English, will it be okay for everyone?
Yes, ma'am.
Huh? Okay. So see here, we are interested only in finding out current through 1 ohm resistance only. Okay, that is the load resistance. So only single voltage source is there now. So obviously conventional current direction, if I use, if current is flowing through this in upward direction, then obviously through 1 ohm, if I am representing current in upward direction, obviously through 1 ohm it will flow in, because same current, whatever the current leaving positive terminal, same will return back to negative, means current flowing through 1 ohm is obviously in which direction?
Upward direction.
Upward direction.
Upward.
And it's a load resistance with second source. That's why I have denoted here IL double dash. Clear? Okay.
Yes, ma'am.
Now can you tell me what's about 4? We are interested only in this circuit to find out IL double dash. That's it. The rest thing, no need to mark rest currents. If required, then only mark. Otherwise, don't. Okay. How about 4 and 2 ohm? How are they connected in?
Parallel.
Parallel. Okay. So what will be its equivalent? 4 into 2 divided by 4 plus 2. You will get it 1.33. See, here I have written in circuit D, 4 and 2 ohm are in parallel. See, in circuit D means this one, 4 and 2 ohm are in parallel. 4 into 2 divided by 4 plus 2, 1.33 ohm. Okay. So this 1.33, you know, so its equivalent circuit you draw now. That will be here. Got it? Is it in series with 1 ampere? 1.33.
Yes.
Right na? See, this branch will remain as it is, and their parallel combination either on right or left, you represent 1.33. I have represented it on right hand side. Complete the circuit. So IL double dash, it will start like this. Current flowing through 1 ohm and 1.33 is same, means they are connected in series. Okay, so IL double dash की value कैसे आप निकाल सकोगे? Very easy. Ohm's law you have to use here. Total voltage divided by total resistance is the total current, and IL double dash direction through 1 ohm is upward, 21.46. This calculation everyone got up to this?
Yes, ma'am.
ठीक है? Can we go for third circuit? Otherwise, I'll
Yes.
stop here because it's 2:30. Whatever you say, I'll do.
We can complete this one.
Okay. Okay. Everyone, if all of you getting fast, please tell me, I'll stop. Okay. See now 40 volt, you consider 40 volt voltage source. Okay. The rest two you make short. So 50, 100 volt shorted, 50 volt shorted, circuit will be like this. Okay. Now only 40 volt is there. So conventional current direction, I'll show here I. Once it reaches through node A, we are interested only current through 1 ohm. So obviously it will flow through downward direction, and I'll represent it as IL triple dash. And we want only IL triple dash. Okay. So how about 4 ohm and 1 ohm? How are they connected in? Yes, in circuit parallel. So 4 into 1 divided by 4 plus 1, you will get it 0.8. See here I have written in circuit F, 4 and 1 ohm in parallel, so it is 0.8 ohm. Okay, and that will be in series with 2 ohm.
2.
Okay, and voltage source is 40 volt. So find out the total current using Ohm's law. Total current you will get 40 divided by 2 plus 0.8. So 14.29. Clear up to this? Yes, total current is required here. Total current you should know. Again the same thing. Total current you know, 4 and 1 ohm are in parallel, and IL triple dash we want. Means what to use? Same concept, current division rule. Okay, so IL double dash is I into parallel resistance 4 ohm divided by 4 plus 1, and that will be in downward direction. Clear?
Yes, ma'am.
This PDF I will post on group.
Yes,
again,
ma'am.
you cross check the calculations. If you have any difficulty, ask me. So now direction we have, all direction we have. See, IL I have assumed. I assume IL downward, and the rest three, IL dash, IL double dash, IL triple dash, its direction was downward. For second one it was upward, and for third one it was downward, right? So with this one you can assume upward also, downward also, doesn't matter. With downward, with reference to downward, this is also downward. So here plus or minus?
Plus.
Plus. For second one it is upward, second one it is upward, minus, and third one again it is downward. See, this is also downward, so with plus. So do it. What answer you are getting? 4.29 ampere, and positive answer I am getting. What does it mean? Whatever the downward direction I have assumed is correct.
Correct.
So have you got the sum?
Yes, ma'am.
I'll post it on group.
Yes, ma'am.
Immediately I will post on group. All of you just cross check. Yours is D division. So can I end meeting? Rest part in next lecture we'll see.
Yes.
Yes. Okay. Thank you all.